Okay, time for another integral today. We've got two methods on this one. I'll jump right into it. What we have ready on the side here is all of our definitions, our definition for cosh and sinh that I can plug in. And that's going to be the first thing I'm going to try is just using that with the definitions here. So we'll start with sinh. It's going to be e to the x minus e minus x over 2. Then for this, we can use this definition right here and just plug in e minus x. So I'll do that and we can go right ahead and simplify. So for the simplification, we can divide in e minus x and think of this like a 1/2 that I can bring out as a constant. So doing that, first dividing e to the minus x into e to the x, we get e to the 2x, just flipping that. And then here on this, basically that's going to cancel with that and just leave a 1. So what we end up with is a very simple integral. We'll go ahead and integrate. What's going to happen, we just got to pop out the 2 there. So we end up with 1/2 e2x minus x. And let's multiply in before adding a plus c. So for my final solution on it, we just get e to the 2x over 4 minus 1/2 x, add a plus c, and that's it. Okay, very nice. Moving on to method number 2. Okay, method number 2, we're just multiplying in the conjugate here, multiplying by 1 over here on the right, but I snuck in another identity, this thing at the bottom, because when we multiply the conjugate, we're going to get difference of 2 squares. It's going to look like this, but that's just 1. So essentially, that's going to just cancel with that, and what we're left with is going to be sinh x cosh x plus sinh squared x. But this thing here, we can just split this into 2 integrals. Let me throw like a dx in there. And then this one, we have another identity for that. Sinh squared x, it's just like the regular trig, just the sign gets reversed. So instead of the power reduction is going to be minus 1/2 plus 1/2 cosh of 2x. So let's see if we can do all this in our head. I'll do kind of in our head, just labeling it, we'll do a u substitution here where all this stuff is going to be du. So that's going to be very simple because when we integrate that, we just get u squared over 2, where the u is sinh, so really it's just going to be sinh squared over 2. And then for this stuff, integrate that, we get minus 1/2 x, just integrating what we did to reduce it. Over here, when you integrate that, that's going to be sinh 2x, 2 pops out in the denominator with this becomes a 1/4. But now for this, we can just use the same identity again. And let me see if I can do this on the fly. We'll pull 1/2 out of everything. Then for this, use this identity here. We get minus 1/2 plus 1/2 cosh 2x. With the half pulled out, we get minus x here, and this becomes 1/2 sinh 2x. But now let me just multiply the 1/2 back in. I probably wasted a step and shouldn't have factored it out, but anyway, let's just do it. So when we do it, we get minus 1/4 plus, here I'm going to reorder it too. Let's bring that x over. So this becomes minus 1/2 x. And then here, you know what I will do though? We're going to have a 1/4 on both these. So let's factor this as 1/4 cosh 2x plus sinh 2x. But minus 1/4, that's a constant that can be absorbed into the plus c. So that, we just make that go away. This thing over here, we saw this before. We just saw it with cosh x, sinh x. When we had it with just x, it was e to the x, but now our input's 2x. So this expression is going to be e to the 2x. Put this all together and reorder it for my final solution on it. We get e to the 2x over 4 minus 1/2 x, add a plus c, and that's it. Okay, there you go. 2 different methods on this one. Let me know in the comments which one you prefer. Thanks everyone for watching today. Have a good day.